Okay, ji. Bismillahirrahmanirrahim. In the previous lectures, we were discussing the packet switching network in great detail, and we understood how data transmission was carried out over our internet. And we also looked at the different advantages and disadvantages using the packet switching approach. And we also understood that packet switching is the technique that our internet communication, the bulk of our internet communication is currently using for data transfer. It's more reliable in sense that, if there is, say, for example, an error in data transmission, that error will only occur for specific packets and the overall data transmission will be carried out easily. Okay, now let's move on to the next aspect of data transmission. Well, the reason I'm calling it the next aspect is because obviously we need to be sure of how data transmission is being carried. There's some aspects that we need to be cleared about. So, for example, with respect to data transmission, we need to understand which direction the data is being carried out. So, is it only in one direction? Is it in the both directions, or simultaneously both directions, one direction at a time? What is it? We have to figure that out. And if that is being transmitted, how many bits is being transmitted at the same time? So we'll be looking into that, the options in this regard as well. If there is any sort of synchronization being carried out during the data transmission as well. So the reason that we're discussing is this is because data transmission can be carried out using different methods, and the variation of methods primarily differ in these aspects. Now, first of all, let's look at the how many bits are being transferred at one time in the form of both serial and parallel data transmission. Now, serial data transmission means that one bit is being transmitted over a single channel or wire. So basically, if you have a lot of data transfer, you're transferring one bit at a time. Now, this method is ideal for long distance data transmissions because there's one problem that is known as data skewing, and that skewing issue occurs when we're using parallel data transmission only. However, there is no problem with respect to skewing in serial data transmission. So it results in a more reliable data transmission medium because there are less chances of error occurring in your serial data transmission. Again, what serial data transmission does, it transmits one bit at a time over a single data transmission. So for example, if this is my sender and this is my receiver, there is only one data transmission line existing between this sender and this receiver, and this only transfers one bit at a time. Now, examples of serial data transmission commonly used in our computers, we'll be discussing this later as well, are the universal serial bus, USB devices. Now, let's look at the second data transmission, which is known as parallel. Parallel data transmission means that I'm transferring multiple bits simultaneously. So usually it's in the form of bytes. So it could be multiple bytes. It could be up to 64 bytes at a time. Now, sorry, 64 bits at a time. So it could be it's usually in the form of bytes. Now, as you can see here in this diagram, I got a channel of 1, 2, 3, 4, 5, 6, 7, 8. 8 different channels, and they will be transferring 8 bits on 8 different channels. Now, what that means is that if I have 1 byte of data, that 1 byte is transferred at the same time. All of the 8 bits are transferred at the same time. So all of these bits will be transferred over these in 1 bit on each individual channel. Now, if this cable is relatively small, so for example, you see your internal cabling of a computer that has cables like this. This is known as a ribbon connector. This is a parallel cable. Now, if the cable is relatively small, it's the length is short, the chances of skewing does not occur. Now, what is skewing? Let's try to understand this. Imagine that I'm trying to send data like in this form. Say that my data is something like 0, 1, 1, 0, 1, 0, 1, and another one. So if this, I'm sending 1 byte completely at the same time, that would mean that the data is being sent in this way: 0, 1, 1, 0, 1, 0, and 1 and 1. So these bits transferred on individual lines are being transported in one go. Now, skewing means that for some reason, I'll explain what that reason is, but for some reason, these bits, when they reach here, they become out of order. Let's just say that since it is possible that they could become out of order, let's just say that this bit reaches the destination faster than the others. So that means my receiving end, my data will look like, since this one got here faster, I have this one at the start, and after that I got a 0, then this one came here, and then this 0, and then this one, then this, let's just say that this one also got here before, and then this 0 came here, and then this one over here. Now you notice that even though I transferred 8 bits and 8 bits reached here, but due to some problem, these bits arrived at different times. And since they arrived at different times, that means their sequence of data has changed. And we all know that in binary data transfer, the only difference between different binary bytes is the sequence of ones and zeros here and there. So basically it looks like an innocent problem that one in, okay, so what? That one came first, so it's written first, and 0 came after. So big deal. They arrived, all bits reached the destination? Yes, they did, but they arrived in different orders. Now arriving at different orders results in a completely different value. Now, if you go ahead and create the Deanery value of this number, it will be different than a Deanery value of this number. As you can see here, bit number 128, the value of 128 is off here, whereas 128 is on here. So obviously this results in a different value. It's a much bigger value than this one. So this is one problem that is known as skewing. Now, because of my arrival of bits in different order, the complete meaning of the data changes. And this results in further, problems in wherever this data is being used for further processing. So it creates a cascading effect that if the data is received here wrong, it will be used wrong, and therefore everywhere else where it's being used will cause errors. So this is what data skewing is. Now, why does that data skewing occur anyway? So that's important to understand. Okay, that these bits did arrive out of order, but why would that happen? This is what's important. As you can see here, these are different cables, and obviously these cables will be made of some sort of conducting material, possibly copper or whatever. Some sort of conducting material is used to transfer these bits over these channels. Now, it is possible that there can be slight variation in the materials used, the conductivity of the cables of these individual channels being used. There can be slight variation. Now, because of the slight variation in conductivity, the rate of data transfer may also be affected of the bits. Now, these tiny changes may cause the bits to arrive out of order, because their varying changes of conductivity result in varying rates of data transfer, resulting the overall bits being shifted around, resulting in a different data altogether. And this is data skewing. Now, if this cable was relatively long, it was a long cable. So I'm connecting my computer with the printer. For example, cable is that long for at least for connecting a computer with the printer. Is for such a cable, if such an error would occur, the chances of such an error would be increased because the cable is long. However, if the cable's length is short, then the chances of skewing don't necessarily have that much of a possibility. So that's why if you are using parallel cable, and we do need to use parallel cables, I'll explain why, but we do need to use parallel cables. Now, if you are using parallel cables, you have to keep the length of those cables short, because if you keep them short, then the chances of skewing are minimized. And a second aspect is also that these cables are expensive. So if I have long cables, that means more cost. So if I have shorter cables, that keeps the cost down and the chances of skewing also down. So that's one aspect of what the problem is. Now, since in serial data transmission, I only have one channel for data transmission. So that means my data, say for example, I'm transferring this nibble right here, and say this bit goes first. So I will transfer this bit it will go first and it will arrive here. Then I will transfer this bit, it will go next and it will arrive here. Then I will transfer this bit, it will go next and will arrive here. And I will transfer this bit, one bit at a time, it will go next and will arrive here. And this, since I'm transferring one bit at a time, the order of the bits is never changed. No matter how long the cable is, there's no chance of skewing occurring here because I'm choosing only one cable and all, their bits are being sent one at a time and the order will remain the same. So that's why it's considered that serial data transmission, it reduces the chances of error, whereas parallel data transmission, if you're using a longer cable, the chances of error increase. Now, I still am can emphasize on the fact that parallel data transmission, despite its setbacks, despite its expensive cost, despite its chances of error, the importance of parallel data transmission cannot be ignored. Why? Because whatever the case may be, parallel data transmission does ultimately offer a higher data transfer rate. Now think about it. You're transferring multiple bits at a time as compared to just one bit at a time. Of course, this offers a higher data transfer rate. So if you want high speed data transfer, you will always have to opt for your parallel data transmission. And if you want a long cables and you want to avoid all sorts of errors, then you will go for serial data transmission. So that's one aspect to consider here with respect to parallel data transmission. So just to quickly recap, serial data transmission means one bit at a time over a single channel. Parallel data transmission means multiple bits over multiple channels. The chances of skewing occur in parallel data transmission, and skewing basically means that the data being sent becomes out of order and ones and zeros being shuffled around result in a completely different value. And the why skewing occurs because the conductivity of each individual channel may vary, and as the distance of the cable gets longer, the chances of skewing also increases. Secondly, if serial data transmission, there are no chances of error because there is only one channel and one bit is being transferred at a time and the order never changes. So long data transmission, long cables, we use serial data transmission because the chances of error reduce. However, since you're only transferring one bit at a time, the data transfer rate is significantly low as compared to your parallel data transmission. Now let's talk about the other aspect of our data transmission, which is whether or not any sort of synchronization is being used. Now, here I have two options. My data transmission can be asynchronous as well as synchronous. Now, the difference between synchronous and asynchronous is that with asynchronous data transmission, data is being sent in a steady stream. And there's just a steady stream of ones and zeros just arriving at traveling from one source to its destination. And there's no timing aspect, there's no time controlled activity whatsoever. It's just a steady stream of bits being sent from the source to its destination. Now, with respect to asynchronous data transmission, it seems like a problem when I want to say transfer different types of data over a channel that supports only one bit at a time. Now, to further explain this scenario, let's consider this example. You have a USB flash drive. Now, USB stands for Universal Serial Bus. We'll be discussing this in a bit detail further down the road. But USB, Universal Serial Bus, states that by the name, it suggests that the data transmission is carried out serially, and which it is. So that means I have a single data transmission line that transmits one bit at a time. So it's serial. So I've got this single channel. I've got this USB flash drive. I connect it. It has a Word file. It has a PDF document, and it has a video file in it as well, an MP4 file. All three files stored in this USB flash drive. I plug it in my computer. A pop-up screen opens, a window opens that shows the contents of my USB flash drive. I select them all by Control A, Control C, copy them, and paste them all on my desktop in my hard disk. As you can see here, what I did was I'm transferring data from my USB flash drive to my hard disk. Now, I am using USB port, so that means data is being transmitted one bit at a time over a single channel, which also means that there's all of these three files are being transferred via a steady stream of ones and zeros. Now, you notice that when the data is copied on your desktop, they are separated as they were in the USB flash drive. The MP3, MP4 file is completely separate. There's no mixing it with the Word file or the PDF file. All data is separated as it's supposed to. It was supposed to, or it was in the USB flash drive. There's no mixing. There's no overlapping of data whatsoever. So what happened here? Even though I sent data over a steady stream, how is it that even arriving at a steady stream of ones and zeros, my computer was able to identify what part of the information or what part of the MP4 file finished, where the MP4 file finished and where the Word file started and where the Word files finished and the PDF file started. How was my computer able to identify that? Well, the reason here is that each data transmission, each separate data transmission makes use of what is known as a control bit. These control bits identify the receiver, in this case, that's my computer, when a particular data transmission starts and where it ends. So if, for example, the Word file is arriving, when it's finished, the Word file is finished, the control bit will be able to identify that now the Word file is finished and everything that's following this is not linked with the Word file, is a completely separated piece of it, is a separate file. And when that, for example, the PDF file finishes, it will also be finished by a control bit, and that control bit will tell my receiving device that every other bit following this thing is a separate piece of data. So this, based on this control bit, the use of control bits, as you can see here, sequence of data followed by a control bit, this, based on the use of this control bits, my receiving device, which is my computer, is capable of distinguishing between the different data that I'm sending. And this is asynchronous data transmission. As you can see, there's no timing aspect. Data is not separated with respect to time. It's only separated with respect to the control bits. On the other hand, if I'm actually using this a timing signal, and the only way I'm separating different streams of data based on that timing signal, then I'm talking about a synchronous data transmission. And as you might have guessed it, asynchronous data transmission is primarily used in serial data transmission and your USB data transmission. In fact, your USB device, your USB port is called a asynchronous serial data transmission port because it transfers data one bit at a time and it uses control bits to segregate data. On the other hand, if I'm talking about internal working of our processor, internal working of our components inside the computer, then I may be using some aspect of timing there, and most probably I am. And obviously, the internal working of our computer is primarily linked together with parallel ports because, as I mentioned before, parallel data transmission supports larger data transfer rates. And there is no place in your computer that is more, that's considered speed more important than any other device is your internal components, your processor, your RAM. Here, the speed is more important, the most important, because your processor is very fast. It is the fastest device. So that means if I have slow transmission device, which I usually do, that means my processor will spend more time waiting. So I don't want it to wait that much. So I want speed to be optimal here. And that's why I will go for parallel data transmission ports. And since internal components are very tiny, the cables are very short, skewing is not a big issue. So anyway, if I'm using timing signals to signify where a particular data transmission has ended and where another transmission has started, and I am alerting the receiver by using timing signals to separate different data transmissions, that is known as synchronous data transmission. And the timings are generated by an internal clock that ensures the sender and receiver are synchronized with each other. So basically, when the time aspect is used, then we are talking about a synchronous data transmission. It is faster data transmission method than asynchronous, obviously, and that is why it is used when time is critical, such as network communications as well as your internal components. Now, imagine, let's take an example of network communications. I have a server that basically provides services to many connected computers. And if we remember about servers, they are basically known as a time sharing system. And we've got a computer here, and a computer here, and a computer here, and a computer here. So we've got four connected. It could be many, but just for example, we've got four. And all of these computers are sending and receiving data with this, basically they're exchanging information with this central server. Now, my server is providing services to these connected computers in a time sharing manner. What that means is that it gives it this connected client or terminal sometime, then it gives it this one sometime, then this one sometime, then this one sometime, then it comes back to this one, then this one, then this one is, and it's switching between all connected terminals so rapidly that each connected terminal thinks that it is the only one connected with the server. So basically my server is sharing its time in this sequence turn by turn with all connected computers. This is a time sharing system. Now, how does my computer know, or how does my server know that the data that I'm right now I'm receiving is, say, for example, from this computer or from this computer or from this computer? How does my server know? Well, obviously, since time is involved here and we're using your synchronous data transmission, my server will know that at this particular clock cycle, I will, or clock cycles or time slice, I'm supposed to be only communicating with this device. And that's why, since it's time controlled, I know I'm not confused that whether data is coming from here, it's coming from here, or it's coming from here. I'm not confused that, because right now it's this device's turn. And I know that no other device will be sending data to me right now, only this device, because it's its turn right now and it's sending me data. And when the time slice expires, I will move on to this device. And at that particular moment, I am not confused or whether it's coming from here or here or here, because at that particular moment, only this device is supposed to be communicating. So and that time slice is allocated to this one. And when the time slice is allocated to this device, then I start communicating with this, and I know for sure that only data is coming from here and data is being sent to this device only. So this is how a networking system is capable of communicating with all connecting devices through synchronous methods and timing signals by sharing its time with all connected devices. So that takes care of synchronous and asynchronous data transmission.